Radar School on KFDX is brought to you by First National Bank and RNC Construction.
So now that we've learned the basics of radar and the basics of reflectivity, another great thing that radar can show us is velocity. Now what that shows us is how fast and in what direction certain particles are moving. These can be clouds in a thunderstorm, these can be just winds itself because these particles are being carried by said winds. And when you look at radar velocity, the color is going to represent the direction that these particles are moving in, whether that be towards the radar itself or away from the radar, and the brightness represents the speed at which those particles are moving. Again, the brighter the colors, the faster these particles are going to be moving from the radar or towards the radar. Now what this does is it shows us really great things as far as what's going on in the weather throughout the day. It can show us straight line wind speeds. How fast are winds coming in just on a normal day? These can show us winds gusting up to 50, 60 miles per hour, but it can also show us winds inside of a thunderstorm, and it's really useful for determining where these storms are going and how fast they are moving, so we can really show warnings of where they're going to be and in what time they are going to be there. And they're also great for showing rotation signatures, which of course is really useful in seeing how tornadoes are forming and where tornadoes are currently. So to show an example of that, this is a classic radar signature. Now this is showing light green particles moving towards the radar. This is of course showing reflectivity, showing that this is producing light rain as far as these clouds are concerned. But as we switch to radar, you see they're all bathed in this green color. That means that they are moving towards the radar site right here in Lubbock. And they're a bit brighter, so they're moving on a bit of a quicker trend towards the radar site. If they were darker, they'd be moving further away from the radar site, maybe on a perpendicular path, because the radar beam's coming out directly into it and moving back into it on there in Lubbock. So if they were moving perpendicular to the radar site, these would be at a zero, technically, radar velocity, because they wouldn't be moving towards or away from the radar just yet. But then, of course, if they moved further away from the radar, they would be bathed in red. So to show different radar signatures, we show here on the tornado, you see that classic hook gecko in the reflectivity. But as you look at radar velocity, excuse me, you do see we have those green colors that are going towards the radar site right here, and then the reds are moving farther away from the radar site. Now because these two velocity signatures are right next to each other, that's how we know we're getting that circular motion and that rotation inside of the thunderstorm. So the hook gecko can be basically your guideline to say, hey, tornado can really be forming right here, and then the velocity can be just that extra kind of data that shows that, okay, there really could be a tornado signature right in here because you get that really tight rotation signature on velocity. So for different velocity signatures, what do they look like? Well, this is the one inside of a hurricane. Radar site is right here, so of course you have those really bright greens that are moving quickly towards the radar site, indicating very strong winds inside right next to the eye of the hurricane, which of course opens up because nothing is there. And then of course you have the reds going really fast away from the radar site, so you have that really fast broad rotation, which of course is what a hurricane looks like. Now something else that happens here very once in a while is a downburst. This is when air collapses out of the thunderstorm and then hits the ground and moves out away from itself. That's what you see here on the radar site, because the radar site's down further to the south here, so the green colors are moving towards the radar site, and these dark reds are moving away from the radar site, and of course you have this little bit of zero radar velocity. That means that the air is hitting the ground in a perpendicular motion to the radar beam, and then of course these two colors represent the air moving out very fast from that particular point. So again, radar velocity is great for showing us the direction and speed at which particles are moving inside thunderstorms or anything else like that. And it shows where and how fast the storms are going to be moving, so it's easier to plot severe thunderstorm warnings, tornado warnings, because now you get a sense of how fast and where these signatures are going to be. And again, helps us find specific storm features like rotation signatures, any sort of rotation, that sort of stuff. So that's how radar velocity works. Next week, we'll go over correlation coefficient.